Imagine a world without numbers. It's impossible. Numbers are how we understand the universe. From the earliest counting systems to today's complex equations, mathematics has always been a vital part of human history. Between 500 BC and 1200 AD, a remarkable transformation occurred. This period saw the birth of key mathematical concepts that still shape our world today. This era wasn't just about new discoveries, it was about building upon the work of previous thinkers. It was a time of cross-cultural exchange, where ideas traveled across continents, influencing mathematicians for centuries to come. This exchange of knowledge created a vibrant tapestry of mathematical thought, weaving together insights from Greece, India, China, the Islamic world, and beyond. This period laid the groundwork for the scientific revolution and our modern understanding of the cosmos. Join us as we explore the fascinating journey of mathematical discovery, from ancient Greece to the Islamic Golden Age and beyond. Ancient Greece, the cradle of Western civilization, was a hotbed of intellectual activity. Among its many contributions, the Greeks' systematic approach to mathematics stands out. They were not content with simply calculating. They sought to understand the underlying principles and relationships that governed numbers and shapes.
Euclid, a mathematician living in Alexandria around 300 BC, had a profound impact on the development of mathematics. His book, The Elements, presented geometry as a system of axioms and proofs, a method still used today. Euclid's work provided a model for rigorous mathematical reasoning that would influence mathematicians for centuries.
Another Greek giant was Archimedes, a brilliant mathematician and inventor. He made significant contributions to geometry, calculating the volume of spheres and cylinders. He also developed methods for approximating pi, the ratio of a circle's circumference to its diameter. Archimedes' work demonstrated the power of mathematics to solve practical problems and laid the groundwork for calculus. While the Greeks were developing geometry, mathematicians in India were making groundbreaking discoveries in arithmetic and algebra. Perhaps the most revolutionary of these was the invention of zero. Indian mathematicians were the first to formalize zero as a numerical digit. This simple innovation had profound implications. It allowed for a more efficient place-value system. This decimal system made calculations easier and is still used today.
Indian mathematicians didn't stop at zero. Aryabhata made significant contributions to trigonometry and algebra. He developed methods for calculating square roots and cube roots, and calculated the value of pi with impressive accuracy.
Brahmagupta made strides in algebra, working with negative numbers and solving quadratic equations. These innovations from India were adopted worldwide, showing the interconnected nature of mathematical progress. From the 8th to the 12th century, the Islamic world experienced a golden age of scholarship. Scholars from Baghdad to Cordoba translated and preserved ancient Greek and Indian texts, ensuring that this knowledge wasn't lost during the turmoil in Europe. They didn't just preserve these texts, they built upon them.
One of the most influential figures was Muhammad ibn Musa al-Khwarizmi. He revolutionized algebra in the 9th century. His book introduced methods for solving linear and quadratic equations.
Al-Khwarizmi's work laid the foundation for modern algebra and impacted mathematics in Europe. The Islamic Golden Age shows the power of cultural exchange and preserving knowledge. Section 5. Mathematical Traditions of the East, China, and Mesoamerica. While the intellectual exchange flourished across Europe, the Middle East, and India, independent mathematical traditions were developing in other parts of the world.
In China, mathematicians developed sophisticated methods for solving equations, calculating areas and volumes, and even predicting eclipses. We developed a unique system of counting rods that allowed us to perform complex calculations.
Chinese mathematicians also made significant contributions to number theory and algebra, independently developing concepts like negative numbers and solving systems of equations.
In Mesoamerica, the Maya civilization developed a sophisticated calendar system and a base 20 number system. we were skilled astronomers and mathematicians, able to predict celestial events with remarkable accuracy. The Maya even had a concept of zero, represented by a shell, centuries before its adoption in Europe.
These examples demonstrate that mathematical thought was flourishing independently in different corners of the world, each culture contributing to the rich tapestry of mathematical knowledge. Section 6. Europe's mathematical slumber. While the Islamic world was experiencing a golden age of scholarship, Europe entered a period historians often call the Dark Ages. With the fall of the Roman Empire, much of the knowledge of antiquity was lost or forgotten. Mathematical progress in Europe slowed considerably. However, even in these times, glimmers of mathematical thought persisted. Monasteries became repositories of knowledge, preserving some ancient texts. The abacus, a simple counting device, remained in use, allowing for basic arithmetic calculations. While Europe was not making significant mathematical advancements during this period, the seeds of future progress were being sown. The preservation of ancient texts, however limited, would prove crucial when Europe began to re-engage with the wider world. The stage was set for a rediscovery of ancient knowledge and a new era of mathematical innovation. Section 7. The Rekindling Translations and a New Dawn. By the 12th century, Europe began to emerge from its intellectual slumber. A renewed interest in learning led to the creation of universities and a thirst for knowledge from beyond European borders. Scholars traveled to centers of learning in the Islamic world, bringing back with them a treasure trove of ancient texts, including works by Euclid, Archimedes, and Al-Khwarizmi. These texts were translated from Arabic into Latin, making them accessible to a wider European audience. This influx of knowledge sparked a renaissance in mathematical thinking. Scholars like Fibonacci, inspired by the works of Al-Khwarizmi, introduced Hindu-Arabic numerals and algebraic methods to Europe. The rediscovery of ancient knowledge, combined with the innovations from the Islamic world, laid the groundwork for the scientific revolution that would transform Europe in the centuries to come. The mathematical concepts and techniques developed during this period, from Euclid's geometry to Al-Khwarizmi's algebra, provided the building blocks for future generations of mathematicians and scientists. Section 8. The Enduring Legacy from Ancient Roots to Modern Heights. The period from 500 BC to 1200 AD witnessed a remarkable flowering of mathematical thought. From the logical rigor of Greek geometry to the revolutionary concept of zero in India, from the algebraic innovations of the Islamic Golden Age to the unique mathematical traditions of China and Mesoamerica, this era laid the foundation for modern mathematics. The transmission of knowledge played a crucial role in this story. The preservation and translation of ancient texts ensured that the insights of Greek, Indian, and Islamic mathematicians were not lost, but passed on to future generations. This cross-cultural exchange of ideas fueled mathematical progress and highlights the interconnected nature of human knowledge. The mathematical discoveries of this era were not merely abstract concepts. They had practical applications in fields like astronomy, navigation, architecture, and commerce. They shaped how we understand the world around us and laid the groundwork for the scientific and technological advancements that would follow. Section 9. A Universal Language, Connecting Cultures Through Numbers. Mathematics is often called a universal language. It transcends cultural and linguistic barriers, providing a common framework for understanding the universe. The period we've explored highlights the power of mathematics to connect people across time and space. From the ancient Greeks to the Islamic scholars, from Indian mathematicians to Chinese astronomers, each culture contributed to the body of mathematical knowledge. They built upon the work of their predecessors, sharing ideas and pushing the boundaries of understanding. This shared pursuit of knowledge reminds us that despite our differences, we are all connected by our curiosity and our desire to comprehend the world around us. Mathematics serves as a bridge between cultures, a testament to the power of human ingenuity and collaboration. Section 10. The Unending Quest Mathematics, a Journey Without End. The story of mathematics doesn't end in 1200 AD, it continues today, with each generation building on the work of those before. The concepts and techniques from this period are still studied and applied today. Mathematics will continue to shape our understanding of the universe. From space to the human brain, it's essential for discovery and innovation. The journey of mathematical exploration is a journey without end.